Hi, this is Adam Griffin with the second video for this week. So this is going to be problem number 3, which deals with mirrors and the mirror equation to find where a virtual image will be based on an object's distance from the mirror and its focal length. So number 3 goes like this. We have an object and it is placed in front of a convex mirror at a distance larger than twice the magnitude of the focal length of the mirror. Give your answer in terms of x and r for each part of the problem. So just a couple of things to note. So it shows in the diagram in the problem that r equals the exact value of twice the focal length. So that means that the focal length is equivalent to r over 2. And we'll be using that later when we use the mirror equation. So part A asks, where will the image appear? And so we have our object right here, and rays are coming off, and they are bouncing off away from this focal point, because that is just, it's how that works. So they look like they're diverging away from this focal point, just like with a diverging mirror. And then right here we have this distance r, this is not distance r, this is where the virtual image will be, and it is the distance x prime from the mirror. And the distance from the object is represented with x instead of s. So the mirror equation says, and I replaced x or s with x, because that's what this problem uses. So the mirror equation says that 1 over the distance between the object and the mirror plus 1 over the distance between the mirror and the image of the object equals 1 over the focal length of the mirror. So we can rearrange this. We can plug in r over 2 for f, which gives us that 1 over f equals 2 over r. So we can plug that in for 1 over f, and we rearrange it because we want to find this value right here, and we get 1 over x prime equals 2 over r minus 1 over x. And then we can exponentiate both sides by -1, so we get that x prime equals 2 over r minus 1 to the x to the negative first power is the distance between the mirror and the virtual image. So for part B, it asks whether or not the image will be inverted, and yes, it will be, because these rays go through, and if it's above the axis, it goes through the focal point and is now below. So points higher up in the object will appear lower down on the image. So the answer is yes, the image will be inverted. And then part C asks, what will its magnification be? And from the textbook, we get that the magnification is equal to negative the distance between the mirror and the image divided by the distance between the mirror and the object. So because we're just doing everything in terms of r and x, we get that the magnification is negative x prime over x. So that is how you do number 3. I hope it was clear, and thank you for watching.